flying saucer.
Okay guys, this is a model I have built. This it's all wood armature. You can see in there all the coils and all the way to the wood shaft. It's pretty tough model, rough. There's no steel, no magnets. It is just about magnetic patterns, and actually the wood and the little wooden shaft is just to hold the wire together. It's pretty, it's got a lot of friction, and it's not perfect, but it's got it to show you that this motor here, it's when I measure it, and let me just finish it so you can read the scale. It's 0. Well, the 0 is kind of digital, but it shows 154 grams, so it's not much. There you go, supposed to go to 0. Now we got this motor here, 242 grams. This one here, 174, and so it's very lightweight, even though it's got the plastic and a whole bunch of bolts, but it's pretty light. I'll be first fitting it linear with just this battery here, so you guys see that it runs. And but I have it connected, the way I have it connected, maybe you have noticed it, it's in parallel. So I'm just gonna jump one side of the motor, this side. As I turn here, the wire exactly the same as the 3-pole. It runs from here, making contact to this pole right here. And this stator is the same as a fiberglass one, except this one doesn't have any fiberglass. And it started at the bottom of it, winding up, and then coming back down again, the same direction all the time. And what the way I have done it, it's 10 each level going up and 10 coming back of 23 gauge. Now the armatures, it's got 70 turns of 23, and I also have well, we're gonna see it now, jumping it at just this LiPo battery, and so you see that it gets too hot. See how this thing got real hot. It's the but it runs, and that's the idea of it. You guys see it turning. As I touch it, and it doesn't get hot. But however, I will be pulsing it. Here it is. There's nothing to it. No magnets, just copper and wood and air. Alright, I have taken this bolt that holds this bracket down, and I will just take these small bolts from the little pins to hold in place and spacers. And the way I did it is I will slide out this whole assembly out, and so you could see all it was. And this is it. It's just a wood armature. Actually, I just used 2 pieces of wood, and this whole center is empty. And this is just the coil for the wire. So I also built a 2-stator, which is the simple one. Smaller amount of wire. This one's got about 60 turns. I cannot have it on for a while, but it's for quite a while run. This is just a model to run it and show on video. It's just 2 coils. I got them out of phase, out of alignment, in order of my explanation before. If they are straight, the vectors are equal opposite, so they will cancel to 0, or to the least. They could be more negative ones run and so on, and it'll give you some kind of AC reading. But this way, they are not canceling out. Their vectors just cross by and will output some current. However, this is just a 2-pole. This is basically for explanation of the whole asymmetrical system, how to understand it, and the way it works is exactly the same as all the rest. It's a 1-stage. It will turn on just this coil, and when the other one will be generating energy at the other side, will be off, and so on. It'll be a continuous mode. Then this one will take a break, go on the other side, will get touched, and we'll keep going. Now the 3 is a much better approach when it comes to asymmetry. Why? Because when it's turning on one side, there are 2 back here making connections and sending output out, or 1 and 2 at each time. There are 1, 2, 1, 2, and the ratio of amount, number 3, it's allows more wire. Like this one right here has 70 turns of 23 wire. I will run next a little, just testing this too, so you see that it also works fine. Okay, so yeah, I got this the 2-pole. It's kind of rough model here, but it'll run. I'm gonna just jump it. So it works beautiful. It's just not. These, of course, these motors will run much better if I oscillate it. It's and actually this coil, like in my previous thread, I can pull by pulsing it, rotation and output from this coil. Same as from the armature. Alright, what I'm going to be doing is getting this tool in here. It's a magnet. It's free, and it's all made of copper and non-magnetic bolts and nuts, and it's just a magnet there. It's a brass handle. These structure here, this kind of pattern what will give you is kind of twisted. Just missed when putting it here. So, but it'll create like in half of it when I'm pulsing. When it's fed linear, it'll cut a north and a south exactly in the center of it because the way it's being wound. And if we fit it linear, it's gonna be delivering a straight north and a straight south inside of it. So that's why the motor rotates like having two stators, solid stators there, but it's actually the magnetic field pattern there. So what I'm gonna do is get this tool inside, right in the center, and here we can do it because it's so and I'm gonna start pulsing it. So you see that, let me see if I, this way it will be better shown. See? That's the motor effect right there. The more pulses, the more it goes in. So basically that's, I don't want to hit it too much. It's a very low number of turns. It's not designed to high pulses of 36 volts. But basically it shows that creates a pulsation there. There's no steel there, there's nothing but copper. So it creates a magnetic pattern. Once that I pulse it, then it collapses, our field collapses, the other one comes in, and that's what makes the rotation. So that's the reason why these motors that I have designed, the asymmetric motors, they work much better on pulsing stators, and armatures are getting pulsed just directly by commutators. So that's it for this demo. Well, what I'm doing here, what I'm going to be doing here is just pulsing it linear from this battery for a little bit only because it's going to get extremely hot, but just want you to see that the magnet is going to remain in the same position. Nothing is going to happen if I just go straight feeding it. There's not going to be any rotation at all. It's just going to stay there, vibrate, but stays there. So see if you can get it here. Okay, that's all. There's just one straight, gets hopefully hot. Now